A box of 1 liter capacity is divided into two equal compartments by a thin partition, which are filled with 2 grams of hydrogen and 16 grams of methane, respectively. The pressure in each of the compartments is recorded to be P atm. The total pressure when the partition is removed will be. So let's consider this to be our box about which we are talking. On the left hand side of the box, we are having hydrogen, and on the right hand side of the box, we are having methane. 2 grams of hydrogen and 16 grams of methane. And they are saying that the pressure on this side is equal to the pressure on this side. Now, there are two ways of understanding this particular question. Let's say if the pressure on both the sides is equal, as soon as you would remove the partition, there would be no actual movement of molecules. Why? Because generally the movement of molecules happens to equalize the pressure on both the sides. Because the molecules move from a region of higher pressure to a region of lower pressure. And ultimately, equilibrium is reached when the pressure of both the compartments becomes equal. However, in this case, the pressure is already equal. So the molecules would not actually move. And the final pressure would remain P. Now, if this way of understanding is not very convincing to you, there's another way to understand this same problem. Let's say we have 2 grams of hydrogen in the left compartment. Let's call this as compartment 1 and this as compartment 2. So for compartment 1, if we have 2 grams of hydrogen, it means that we have 2 divided by the molar mass of hydrogen is 2. That is 1 mole of hydrogen. And in the second compartment, we have 16 grams of methane, which implies 16 divided by the molar mass of methane is 12 plus 4, which is also 16. So 1 mole of methane. Now when the partition is removed, the mixture would contain 1 mole of hydrogen and 1 mole of methane. So the mole fraction of hydrogen will be 1 by 2 and the mole fraction of methane would also be 1 by 2 because 1 is the number of moles of hydrogen and 2 is the total number of moles in the mixture. We know that the partial pressure was the pressure exerted by that particular component. So P will be defined as the partial pressure for hydrogen and P is also the partial pressure for methane as is mentioned in the question. So therefore, we can say that the total pressure is what? The mole fraction of hydrogen times the partial pressure of hydrogen plus the mole fraction of methane times the partial pressure of methane. So the mole fraction is 1 by 2 multiplied by P plus 1 by 2 multiplied by P, which gives the answer to be P. So therefore, the total pressure of the mixture is P. That is option A.